Here we have our last two targets of Unit 1, Target 9 and 10. And so you'll notice that we have some situations here. So we're going to use what we already know about writing equations, inequalities, and discuss some domain and range in those context situations. So if you look at target 9, it says I can write an equation and find the domain and range of a linear function given a situation. So the very first part of that target says I can write an equation. So that's what we're going to focus on, and then we'll get to the domain and range part of the problem. So our situation is about Kanaya, who has a summer job at the St. Louis City Museum, and it pays $11.50 an hour. It says she works 15 to 30 hours per week, and we're going to try to find the domain and range of Kanaya's weekly income. So starting off with that equation, notice that it says that the St. Louis City Museum pays $11.50 an hour. So we're going to come up with an equation that represents that statement. We're going to think about slope-intercept form, so y equals, and the slope in this case would be $11.50 per hour x. So just to define what x and y mean in this situation, x would be the hours that Kanaya works. So it's $11.50 per hour. And then y in return would be the amount of money that Kanaya is bringing in, or her income, I could have also written. So let's go back to what we know about domain and range now that we have our equation. Remember that we know that domain goes with the variable x and range goes with the variable y. If you can remember that, then these last two steps are pretty easy. So if the domain is x and x represents hours, then think about the word problem. It says that she can work 15 to 30 hours. So she can work 15, she can work 30, she could work 20, but she couldn't work something like 11. It would be outside of that range of values. So we're going to use a compound inequality to write our domain, starting with the least amount of hours that Kanaya could work, which would be 15. Now I'm going to use an inequality symbol. I'm going to write is less than or equal to. So I'm going to put x next, since that's the variable we're talking about right now. So the way that I read what I have written so far is that x has to be greater than or equal to 15. Or I could say that 15 is less than or equal to x. I put the equal to because 15 is a possibility. Now we're going to think about the high end of that value range for domain. So the high end is 30. So x also has to be less than or equal to 30. So this is a compound inequality. We have x in the middle because we're talking about the domain, which goes with the variable x. I have an equal to component on each of the inequalities because 15 and 30 are both possible. So now looking at the range, which is y, it's talking about money. So if you look at the equation, remember we defined y as money. So let's think about how much Kanaya could actually bring in as her income. The least amount of money that Kanaya could bring in is if she worked just 15 hours. That's the very lowest amount that she would ever work. So let's think about how much she would make if she worked just 15 hours. That would be $11.50 times 15 hours. So $11.50 times 15 would give you $172.50. Kanaya will never make less than that because she's never going to work less than 15 hours. And then our inequality is going to look similar, but we're going to use the variable y since we're talking about range. Now we're going to talk about the high end of the range, and the high end of the range would come into play anytime Kanaya worked the full 30 hours. So $11.50 per hour times 30 hours. So the most that she could possibly make would be $345. So we have our domain and range, and that was all based on the equation that we started with. So the process here is going to be the same for all of these problems. It's just going to be different numbers. So Joseph's in Algebra 2 and his stomach starts to growl. Third lunch is the worst. he decides to run to the vending machine to grab some fruit snacks to hold him over to lunch. Each fruit snack is $1.25, and he knows he'll need to purchase he'll need to purchase 2 to 3 bags to fill him up. What is the domain and range of his purchase? So remember, the first thing that we do is we write an equation. So it looks like each fruit snack is $1.25. So in the first problem, we were talking about how much Kanaya was making, but here we're talking about how much a fruit snack costs. So y equals, and each fruit snack is $1.25. Then I'm going to have that variable x. And again, I'm going to take a moment here and define what x and y would be. So x would be the number of fruit snacks, because it's $1.25 per fruit snack. And y would be the amount of money spent on fruit snacks. So just defining the x and y makes it easier once we get to domain and range. Again, remember, domain is x, range is y. So the first thing we're going to look for domain is any kind of restriction on the number of fruit snacks. So it says here that Joseph would purchase 2 or 3 bags. So the maximum would be 2, the minimum would be 2, and the maximum would be 3. So going to the domain, the very fewest number of bags would be 2. We're going to use x, and remember, I did use that equal to component because 2 is a possibility. The maximum number of bags that Joseph would purchase would be 3. So that domain is always given in the word problem. The range is something that you're going to have to calculate, and that's true for every single problem here. So now we've got to figure out what would be the least amount of money, because remember, y is money, that Joseph would spend. And that would be the case that Joseph only purchased 2 bags. And remember, they're $1.25 per bag, so that's why I used that calculation. So the least amount of money that Joseph is going to spend is $2.50. I'm going to use y because we're talking about range. And the most that Joseph would spend is if he purchased all 3 bags. So we would do 1.25 times 3, which would be $3.75. In our last problem, we have the Jetson family, and they're going to go bowling, and they have a coupon for the Brunswick Bowling Alley. They can pay $10 for their first game, and any game after that will cost $5. George has a baseball game later, so they'll be able to bowl 4 games at most. What's the domain and range of the Johnson's family bowling outing? Okay, so let's write our equation first, and this one's a little bit trickier because we have a couple things going on. So this coupon says that they'll pay $10 for their first game, and any game after that will cost $5. So it's $10 for the first game no matter what, but $5 per game after that. So y equals, and since the slope here would be $5, because most of the games are going to be $5, we're going to write 5x. But then we have that original $10 that we've got to tack on for that first game. So this one has a slope and a y-intercept. We're going to define x and y. So x would be the number of bowling games. And again, notice the pattern here. Y would be the cost. I'm just going to define it as money again, so it coincides with the 2 previous problems. We have x and we have y. Now, if you notice here, it says they'll be able to bowl 4 games at most. So when it comes to the number of bowling games, there is a restriction here, 4 games at most. So I'm actually going to start with the high end. We know that that's going to be 4. So I'm just building that domain backwards. So let's think about this logically. Now, it would make sense that the fewest number of games that they're going to bowl would be one full game. Technically, they could bowl a half of a game. They could bowl a quarter of a game. So what I'm going to do for the domain is I'm going to start it at 0. However, 0 is not a possibility because it says they are going to go bowling. So I'm going to use the less than symbol without the equal to because 0 is not a possibility, but they could technically bowl half a game. That's a little bit of a waste of time, but it doesn't say that they can't. So we have to go with that restriction. For the range, we're going to plug in these values to the equation we wrote. So starting with 0. So 5 times 0 plus 10 would give us 10. Now, because 0 games is technically not an option, 10 is technically not an answer. So it's going to follow whatever the previous or whatever the domain symbols are. And then on this end, because we did have an equal to 4, we are going to have an equal to on this end because there is a clear maximum, and the clear maximum would be 4 games total. Now actually, when I write this, if you think logically through this, I just wrote 5 times 4 plus 10, but really it would actually be 5 times 3 plus 10. That's kind of tricky here because, let me write that. Because remember that 10 is the first game. So if we're talking about bowling a total of 4 games, we have the 10 that represents 1 game, and then we have 3 more. So that's kind of tricky. You got to reason through that. So 5 times 3 plus 10 would be 25. 25 is the most that they will spend at bowling. All right, for our last target for the unit, we have something that's very similar to what you were doing on the front, but now you're going to do an inequality. And so the difference here is that you're going to be able to spend up to a certain amount. So we're going to be talking about budgeting. And if you think about budgeting, a budget would be a very high amount of money that you could spend on a certain thing. But you can always spend under budget. That would be appropriate. So we're going to use inequality symbols instead of writing an equation with an equal sign. All right, so it says you have budgeted $175 a month to spend on a car, including the monthly payment and gas. Your car payment is $133 and gas is currently $2.60 per gallon. So the first thing we're going to do is write an inequality and we're going to solve it to represent the number of gallons of gas you can purchase in a month to stay within your budget. So let's think about, kind of like we did on the front, how we would write an expression to represent the situation. So the variable here is gas because it's $2.60 per gallon. The car payment is going to be the same no matter what every single month. So when we write our expression to start with, we're going to write 260x because that's technically the changing value, that's the slope, plus 133, which is going to stay the same no matter what because that cost, that monthly payment for your car isn't going to change month to month. Now notice I didn't write y equals here because we're talking about a situation where we have a budget. So this is the amount we're going to spend per month, and it has to be less than or equal to that budgeted amount. And if you look at the first sentence or the first statement, it says that has to be less than or equal to $175. So now what we're going to do is go ahead and solve this inequality like we did earlier in the unit. So I'm going to subtract 133. So now just writing what I have left, kind of running out of real estate there, I'm going to go over here. So if 260x is less than or equal to $42, I'm going to divide by 260. and I get x is less than or equal to 16.154. Okay, so technically, in this situation, we could purchase 16.154 gallons of gas. But what we're going to do is go ahead and round that down to the nearest whole number, which would be 16. So we're going to say x is less than or equal to 16. We don't want to go above that because if we went all the way to 17, we would go over budget. So again, just kind of thinking about what would this represent, and I already stated this, but X would be the number of gallons of gas. So if we go over to domain and range, we have X and Y. So it says that we have to stay under 16 or equal to 16 for the domain, for the X, for the number of gallons of gas. So what we need to think about is what would be the least amount of money we could, or the least number of gallons of gas. Technically, you could purchase 0 gallons of gas in a month. If you're really not traveling anywhere, maybe you just filled up before the month began, and you are just staying home, then you could technically purchase 0. So when I write the domain here, I'm going to include 0 because it is a possibility. It doesn't say you have to travel. Then we have our variable x for domain, and we solved to find the maximum number of gallons of gas would be 16. So you do have to go through this solving process to figure out what your high end on your domain is going to be. Now we're going to find our range, and so when we find our range, we're going to go back to this expression we started with, and we're going to plug our values in there. So starting with 0, we have 260, our low end is 0, plus 133. So the least amount you could spend per month on your car is 133 because you always have to make that monthly payment even if you aren't driving it. So less than or equal to y, because we're talking about range, and then we have the high end of our range. So that's if you purchase all 16 gallons. So 260 times 16, and then we have that monthly payment of 133. I'm going to throw this into the calculators. And so that would come to a monthly cost of $174.60. And that would be the most that we would spend, which is great because it does stay within our budget of $175. So notice that that $175 isn't necessarily going to show up in your domain or range. It's just giving you that original criteria to stay under. All right, so our second example, we have Calvin, who has $20 to go see the new blockbuster hit at the movies. His ticket to the movies costs $7.50. If Blue Ices costs $5.80 with tax, what we're going to do is write and solve an inequality to represent the number of Blue Ices Calvin can purchase at the movies to stay within budget. So starting off with our expression. So the ticket costs $7.50. It doesn't matter what else is purchased, what other snacks are purchased, the cost of the movie is always going to be $7.50. The Blue Icy costs $5.80. Now we could purchase one Blue Icy, we could purchase 2, 3, 4. Probably going to throw up if you drink that many, but hey, go for it. So let's write our expression. So the thing that could change is the number of Blue Ices that you purchase. So 580x. That 750 doesn't change. It doesn't matter how many Blue Ices you purchase, that ticket costs the same. And then we have a budget, so this amount needs to stay less than or equal to $20. And just like we did on the first one, we're going to go ahead and solve this inequality. So let's subtract the 750 over. So then we have 580x is less than or equal to 1250. I'm going to divide by 580 to get x by itself. and we get x is less than or equal to 2.155. So let's think about what x represents. X represents, if you go back to that original expression, the number of blue ices. Now, I don't know if you've ever asked for 0.155 of a blue icy, but you're probably going to get whoever you're asking to look at you like you have 3 eyes. So you can either purchase 2 ices or you can purchase 3 ices. According to our expression here, if we purchase 3 ices, we've gone above budget. So let's round down, and notice I'm always rounding down. Even if it said 2.9, I would still round down to 2. This is the number of ices. Okay, so let's go write our domain and range. So let's think about the fewest number of ices that you could possibly purchase. It doesn't say that Calvin has to purchase a blue icy, so the least amount would be 0. That's a possibility, so I'm going to say equal to here. We just solved to find the most amount of ices that we could purchase would be 2. So then our range is talking about the amount of money we'll spend at the movies. So again, just plugging those x values into our expression. So the least amount we would spend at the movies is going to be just $7.50 if we just purchased the ticket. So again, I just plugged in 0 to our expression, and that's where I got $7.50. The most we'll spend, it has to be under 20, but the most we would spend is if we purchase 2 ices plus the cost of that ticket, which was $7.50. So I'm going to plug that in my calculator. And I'm getting $19.10, which is great because it does stay within that $20 budget that we originally had.